Thank you. Thanks. Hi, everyone. My name is Fakiri. I'm one of the guys working at Cloud66. Just a little bit about who we are, what we do. So Cloud66 is everything you need to have to run a Docker-based container application in production on any cloud on your own servers. So the way it works is we either build the Docker images for you from your source code, or you have your own Docker workflow. That's great, and you build it. You give us the images. We then connect to your own cloud provider of choice, DigitalOcean obviously, and the usual suspects. We connect to those, fire up the servers for you, provision them, roll out the containers, and we also do a lot more than just taking care of containers. So there is a lot about web traffic, your visitors, the databases, replication, backups, access control, audits, firewalls, security, patching of operating systems. So it's basically the whole stack of running your application in production on any cloud provider. So that's what we do. We get a little bit like of how it works, a little bit more than that, but I'm sure you're not really interested in Cloud66. You're more interested in like what we're going to do to help developers use Docker. So to start and make sure that I'm on the right track, I want to ask a couple of questions just for my own sake. How many of you have used Docker in development or production? Great. How many have not used it in production? Okay, so we have a lot of people who have tried it in development but not in production. Right, great, cool. So I think the best way for me to start is to tell you about a couple of projects that are open source free, sponsored by Cloud66, happens to be, but we find them very useful, both for our own customers, but for ourselves. This is what we built for ourselves primarily, and we're sharing it. And I think you will find them very useful. The first one is the starter, which is what it does is essentially it's the easiest way to take your application into production or into a Docker file and make it Dockerized, right? And it's fairly simple what it does. It's an executable. It's obviously open source, and it's written in Go. You can compile it yourself if you want. You can contribute hopefully later on. But you get it on your laptop. Then you point it to your project. Let's say you have a Rails application. You point it to your project, and then it reads your source code, tries to do some basic analysis of it, and then spits out a Docker file. So that's the first step. Usually it's good because we have a lot of intricacies around how to build Docker files, and Tom is going to talk a little bit more about how it's actually worked out in production for DigitalOcean internally. But there's a lot of quirky things that you need to take care of when you're thinking about Docker files, and I'm sure you've realized that when you were doing Docker in development. And then it spits out another file as well, and that's called service YAML. That's specific to Cloud66, so you can use that file to then take your project, your Docker file, and the service YAML and host it on a DigitalOcean server. But I'm pleased to say that since last week, we've released a newer version of Starter that spits out a Docker Compose as well. So if you don't want to use Cloud66, fine by us. We would love for you to try it, but people have different preferences. You can use Docker Compose, run it in development. If you ever get into production, hopefully, we'd love to have you on Cloud66. So let me show you a little bit about what are the things that we do at Starter. So we're all familiar with Docker files and how they work. Just a brief, kind of quick thing. I'm going to use a high-tech system I just discovered. I keep pressing this just to make sure that I can pair it with Bluetooth. I couldn't do that, but I realized that it's got laser. So, so Docker files, they have layers. You start from the base, and then you keep building these layers on top of each other. This is like a Java application. So you have a base of Linux. It's a Debian one. So those two essentially are the one instruction on your Docker file. Then you install your application server, your runtime, your application, well, the web server, and then application server. Then your application comes here. And here's the runtime, the file system. And the reason that's in red is because when you do Docker, obviously, you have your container running, the result of the image going into a container. Any change in the file invalidates the last layer, right? Which adds a kind of a challenge if you think about it that way. Now, who's familiar with like Rails as a framework? OK, that's great, cool. Sometimes I go to like a node crowd, and I find myself completely out of skill. All right, great. Okay, so, for those who understand Rails, and it's fairly simple. You have like in Node, you have packages. In Rails, you have gems. In Python, all languages have these libraries, gems, shareable things. And there is a step always in this installation that you have to build those and download them from the GitHub usually, put them next to your application so your application is compilable essentially on its own, right? And every time we do something like bundle install in gem or npm install, we're changing a lot of files, which means that layer on top is changing a lot. So every time I have a Docker file, I add my source code to it, I run docker build, I'm downloading an npm install, for example, and then all of my files are invalidated, although I have not changed anything in your application. Now, what's the likelihood of me changing my code versus the likelihood of me changing a dependency of the application? I'm more likely to change the code than add a new gem or an npm, right? So you don't want to rebuild and invalidate all the cache layers based on that. So let me show you how a basic Rails, in this case, Docker file can look like. I start with the base, like a Ruby latest, which is a sanctioned Docker Hub official language. And I do a bunch of things here, which is usual, update, install, and then build essentials, Node.js for asset pipeline compilation, uglifying of the JavaScript files and squashing, compiling Sass and everything around that. I create the environment variable, then create that folder, set my work directory there, add my gem file, which is like my package dependencies in Rails. Think npm package JSON. Install those, which pulls them down, pulls those gems or npm or whatever package you have from GitHub, installs it, and I add my application from local build context to the folder, right? Now, it's kind of funny because this will essentially add that as well, because this gem file lives inside of that folder. But as you can see, as we kind of talked about it before in the previous slide, I want to add that one first because the likelihood of me changing this is way less than this changing. So I add this one first, and then every time I change this one, of all these layers, each one of them obviously turn into a layer in Docker image, only this one gets invalidated. So my build becomes much faster. And that's basically one of the things, one of the most basic kind of best practices that you can do with Docker. Any questions so far? Cool. It's basically the same. Right. So if I were to feed one Rails application into Start, and I'll get into demo, the exciting part, excuse the slides, what are the things that we need to look into? First, we need to look into what gems, for example, you use, right? Now, if I wanted to just write Rails Docker file, obviously would be very simple. Add the gem file, add the source code, and then run a bundle install, get it built. But you might be using memcached, you might be using Redis, MySQL, Postgres, all sorts of things around that. ImageMagick. What are the dependencies for those things? What Linux packages do I need to install, for example, to have ImageMagick running in my Docker? Pretty much everything. Well, that's what we do, like stuff. Exactly. Luckily, it's not the same case for everything. So if you think about Postgres, you have just Postgres client, drivers, and things like that. And that's what Starter does. So it reads your gem file in case of a Rails application. Well, obviously, the first step is to detect what framework you're using. So it uses for clues. Oh, it seems like a Rails one. Starts with that, reads the gem file, and says, I can see ImageMagick. I'm just going to add a boatload of packages to the add part of the in an apt install. I can see that you're MySQL, so I'm going to do MySQL client. Then it looks at your database YAML, so it creates the environment variables that you might want to need, and are fairly standard, MySQL password, MySQL username, MySQL host, URL, whatever else. And then also, every framework has its own kind of commands that you have to run. Again, going back to the example of Rails in this case, you have database migrations that change the schema of database. You want to run those if you have any database migrations. So those are the commands that you run at every build that you want to do that, right? Let's get to demo. OK, so how to install Starter? It's fairly standard with Brew. If you're running a Mac, pretty much everybody does. You should be able to try it now if you have internet. You basically just tap the Cloud66 tab, do a Brew install Cloud666 starter, and you're up and running. It's a Go application. You can go to that URL. You see it on GitHub. Compile it yourself if you are into Go. It uses Go 1.5 experimental, which uses vendoring as well, so you shouldn't need any dependencies coming from the internet. It has everything you need to build it. I'm going to share the slides as well in case, so don't worry if it doesn't. OK, cool. Now, here's my application. Right. It's a fairly standard Rails app. It doesn't do anything fancy. I'm just going to run it now. What I'm doing here is I'm saying Rails server binded to all my network cards and start. Anybody see this? Do I need to make it bigger? All good? Sweet.
A little bigger, please.
A little bigger. Is it good? Or more bigger? There you go. Should be OK. Right. OK. Let's see what it does. It's a super complex thing. There you go. Fairly simple. It's got a SQLite database. Every time I refresh, adds an increases the counter, writes it to the database, and just as a random style on CSS, right? If I stop this and run it again, we were on 21. It goes 22, 23. So it is writing to database, okay? And this is a kind of point that I want to demonstrate somewhere. OK, let's put this thing into Docker with starter and run it in production. Here's what I'm going to do. I'm going to go to starter. I'm running my starter that I just built, so I'm using .starter. I'm pointing it to that project. OK, so it detected that I'm using a rack-based framework, Rails. It couldn't find the version of the Ruby because I did not explicitly say what version of Ruby I'm using. So it's just going to say, I'm assuming latest. I'm going to assume latest. If I had something that said like Ruby 2.20, then it would add that, try to find that image on Docker Hub and use that as a from statement of your Docker file. I'm going to say yes. Now, it couldn't find any databases because SQLite kind of comes with everything that it needs. It doesn't need anything extra. Had I been using like MySQL 2 gem, then it would say, it seems you're using MySQL already. So I can demo it to you. I'm not it's not vaporware. I'm going to say there is no database. And these are a bunch of Ruby or Rails specific commands that it just suggests that you might run. What this one does, I mean, this is all gunk. This is the important part. Basically says, load the schema to database. Your database has the schema. I'm just going to say, yep, that's good. It's going to run it after each build. And then after each deployment, it's going to do the migrate my database. So in case I have a database migration, it will run it. They are not applicable to this case, but it's nice to have it. OK, there we go. So what it did is it created a Docker file and a service YAML. Let's go and see what Docker file it created. As you can see, it didn't create any. Oops. OK.
You have to run the starter twice.
Yes, exactly. You got me. So the reason it works this way, not the twice part, the reason it writes the Docker file into your source code and not nowhere else is basically, it's based on an assumption that I have my code, and usually my code and my Docker file kind of live side by side. If I add image magic, then I'll have to go to my Docker file and add a bunch of packages. So every version of my code is supposed to work with the same version of a Docker file. So they kind of are lockstep. And that's what it does. Fairly basic stuff, adds it there. But I can customize it. So it drops it in my source control. I can do a git add and add this to my source control, and that's my starting point, hence the name starter. But you have other abilities of saying, okay, this is a good start. Now I'm going to go and modify it, customize it, add my own packages, things you starter couldn't detect and identify. And that's fairly simple. We've seen all of this. Obviously, now you can identify that combination of these two commands together allows me to do all this in one layer instead of creating another extra layer on top and all things like this. And I'll get to that with when I'm talking about Habitus, which kind of takes care of these more advanced build structures. So that's that. Let's see if I can build this. So I'm going to go to this file, say docker build. Right. That's all I did. So now I have a Docker file, a Docker image. Let's run it. My Rails application is on port 3000. Let's see what's in it. I need the name. Okay. Here's my application. Okay, I'm running it inside. Now, one thing I need to do is to find my container's IP address, which is my Docker host IP address. And there you go. So now it's running inside of Docker container. Fairly simple. Now, you remember last time I stopped the one that was running natively, and I started again. It started from 21 to 22, so it was actually in the database. Now I'm going to refresh. So we were 25, 30, 34. I'm going to stop, kill the container, start again. I'm back on 25, because the database was the one that was persisted on the image. So that's a starter. Fairly simple. It just gets you a head start into having your application, usually web application, into this. And it does just slightly more than this. As well as detecting the framework, it would try to guess the port on the web server you're using. It also is compatible with proc files if you've used like Heroku, where you know that you have background processes that you want to run on proc files, like queue managers or email background senders and things like that that are not web service centric, and you usually put them in a proc file. So it would go and detect those processes and creates a new line for each one of them. So you basically can end up with a service composition of a bunch of containers, each one of them running your background processes, and then one for your web. And you can scale the web one, obviously. Don't scale the backend ones. Here's an example of a service YAML now it creates. So I mentioned that one of the other files that it creates, starter creates, is a service YAML. Service YAML is a service composition file that we use at Cloud66. Think of it as Docker Compose for Cloud66. It's more production-centric than Docker Compose, which is more developer-centric. So it's fairly simple format. I'm sure you're familiar with it. I have one service here, which was my web. Where do I get the Git repository source code for it? What branch that was? What command I need to run the server? What's the build and deploy command? The schema load and the migration, which we saw. Where is my build route? It's with the context of that build. Again, fairly simple. The port is on 3000. Now you notice that there's port 80 here instead of 3000, which basically means when I put it on production, I prefer to have it on port 80 as opposed to port 3000. I don't want to tell my customers to go on my domain colon 3000. And a bunch of standard environment variables. Am I going too fast or too slow, or is it good? Who thinks I'm going too fast?
Me.
Okay.
But it's okay. Keep going.
Ask questions. Okay. I don't want to leave anybody behind. Just ask questions.
Yeah.
Interrupt me.
Keep going. I'll jump in.
All right. Cool. Now I'm going to show you a little bit more complicated service YAML, just a little bit about how proc files are, and then we're going to put this into DigitalOcean server. So Cloud66, the main application, the web application of Cloud66 itself is written in Rails. Woo! That's why I'm so Rails-centric. And I'm just going to run starter against Cloud66 itself and see what it comes up with. So I'm going to point it to the project that we internally call Maestro. Right. So again, we're not explicitly saying what version of Ruby we want. So it finds that. And it found MySQL this time. I'm saying yes, it found Redis, Elasticsearch, and these are the 3 databases that we use at Cloud66 in the backend. Any other databases? No. It also found a proc file. And as you can see, we're using custom web, which is Unicorn for us. It's not Passenger, which is another application server for Ruby. We use Unicorn, which is what we prefer. Fay, which is our WebSocket real-time communication mechanism that updates everything and sends logs back to the UI. Scheduler, which is, you know what it is. And then you have different priority background workers. And it just found that. And again, it's going through load the schema, migrate, and spits out the files. Let's have a look at the files. So Docker file is, again, the same in this case. But here is the service YAML. Again, my web is running there. It detected that I'm using Unicorn. So it's using Unicorn instead of Rails S, or WebRick, which is the name for that. Now, I've got Fay, which was my WebSocket communicator. As you can see, it found out that I'm running Fay on Thin, which is another application server that handles WebSockets for us. Adds it there, detected the port, 8080, and it's just going down to every single one of those processes. Now, at the end, just going to bring it a bit higher so you can see, there's a section called databases. And this is kind of the part that we're different from Docker Compose. Because we at Cloud66, when you run your application on Cloud66, we run your databases on a VM. We don't run it inside of a container. Because of that, if you tell us that you have MySQL, what we're going to do is we're going to connect your DigitalOcean account. We're going to fire up a single server, provision MySQL on it, the version that you want, and you can specify which version you want and all that sort of stuff. We fire up a MySQL. We fire up another server to put Redis on it. We fire up another server to Elasticsearch. Obviously, you can say, I want to share like Elasticsearch with Redis because my search load is not that much. But then what it allows us to do is you can just go to Cloud66 dashboard or the command line and say, I want replication. What happens then is Cloud66 will connect to your DigitalOcean account, fire up another server, based on that, create a replication for you. As simple as that. And you can say, I want to have another Redis. And you can actually have things like, I want to have my main replica of my main database in Amazon and my backup on DigitalOcean. You can have cross-cloud, cross-data center replication even. So that's kind of a more complicated setup. Now, you saw the application. Let's go to Cloud66. That's how Cloud66 looks like. This is my dashboard, and we do a lot of dog fooding or drinking our own champagne or whatever that is called. And we deploy Cloud66 pretty much with Cloud66. So what I'm going to do is I'm going to get the Docker file that we created and the service YAML and see if I can host that application up on DigitalOcean. OK, so here what I'm going to do is I'm going to give my stack a name. I'm going to say what environment I have, and you can create environments as much as you want, as many as you want. This is my web. Where did it come from? That's my source code. And I can use the service YAML here, but in this case, I'm just going to show you the old school way. That's my Git. My service is available on port 3000. I did not use any databases, obviously, while it's SQLite. I'm going to say next. OK, so now I have an option of choosing a cloud provider that we support or deploying on a server that I already have. I'm going to say a cloud provider. Obviously, I'm going to choose DigitalOcean. I'm going to go to New York 2, say, and what size of server I want, say 1 gig. Off we go. It's going to start building it. So DigitalOcean is going to give us a server under your account. This was actually my account, but it will be yours. Give us a server. We then connect to it, blast it with basic everything, package it. We don't install anything that's ours apart from one open source agent that monitors your IP address changes in case you bounce your box or there's a crash or DigitalOcean decides that they want to move it to another physical, so the IP address might change, and also monitor the heartbeat to make sure that you know if your server becomes unavailable. And this unavailability could be because the network's got an issue or it's under huge load, so you can't even run a cron because your CPU is saturated. That's it. Everything else is exactly your server. You can SSH to that server. You look around. It looks like exactly you run your Ansible or Chef or Puppet or whatever Roxyboat scripts on it yourself. You'll find everything the same way. Everything is open source. There's Nginx there for your web. If you have a load balancer on DigitalOcean, we can actually do load balancers, which is HA proxy. We can do that. And if you're using, say, Amazon, then we do ELB. You can just do whatever you want. OK. This is going to take a while because it's going to just build and install all that sort of stuff. So here's the one I prepared earlier when I was in that room. So this one's building. This is the one I created with the same setup. And here it is. So as you can see, I did that before a couple of refreshes, so I'm on 4 here. And you can actually go to that URL, firefly.docker-101.c66.me, and you'll see the app. And that was as simple as that. We didn't do anything fancy. I can do exactly the same thing and have databases and everything else around that. OK, great. Any questions so far? Sweet. OK, so that was Starter, which is about getting started with Docker. It supports Rails, Node, basic Python, Django, not much of it. We hope that you like it. We hope that you contribute to it if you want. As again, it's something that will help everyone, and it doesn't not necessarily just create Cloud66 files. It would do Docker Compose as well. If you are a Java developer and you want to contribute to that, you're more than welcome to do that. Now, the next project that I wanted to talk to you about is called Habitus, which is kind of slightly more advanced, I would like to think of it. It's another open source project that we are announcing today as open source. It was closed source till now, and yay. And we built it for ourselves, and I'll tell you why we had to build this thing. And we use it quite heavily ourselves. If you're into building Docker images, you'll realize that's a useful thing. And now we're working with CoreOS and a bunch of other companies just because they love it, they want to contribute to it as well, which is quite cool. So what is Habitus? It's a Docker build tool. So you can see it on habitus.io. I don't know why the logo looks like an elephant's bum, but here we go. So what does it do? Normally, you create a Docker file, which is quite simplistic. You create a base, and you create a bunch of layers on top of it, and you have a Docker image. But what if your build is more complicated than that? What if you have some scenario like this? Let's say I have a Java application, or a Go, just because I like Go. I have a Go application. I have to build it, i.e. compile it. Then I want to have 2 images created on that, one for the API, one for the web. And then I want to upload it to my S3 bucket so everybody can download them, right? It's more of a complicated build. But as well as that, there's another thing going on here. When I compile a compiled language like Java or like Go, I have to build that image with compile libraries, with compile time libraries. Like, for example, you might want to have if you're doing like ImageMagick, or if you're doing Go, you might want to have GCC, like your C library, your C compiler. You might want to have some libraries, which you won't need if you're running it in runtime. What it would do is it loads the image, makes it slower to download, and just uses more space. But I think more importantly, it increases the attack surface, packages that you have to keep up to date, and just it becomes a group picture with a lot of people moving around. So you might want to do something like, I want to create this compile time image, compile it, then take out the compiled one, put it into another image, build that one, and then take the artifacts of that and upload it to S3, something like that. Or even something more. Imagine that you want to pull out the code from Git repository, and it's your private Git repository. You need a private SSH key. If I go and say git pull as a layer in my Docker file, I need to have an add command in my Docker file that says add SSH private key there. And by just doing that, I've added and included my private SSH key into a Docker image that somebody might just go and say by mistake, Docker push, and that's it. It's public. Everybody's got my private key. So what do? You have to take that layer out, or you have to pull the private key from somewhere else. And if you take the layer out with a delete, obviously it's kind of in the history. It's like Git history. You cannot rewrite history in the majority of cases. So therefore, it doesn't matter if you do a delete. You want to squash that image, essentially just yank out that image altogether, that layer. So these are the things that Habitus does. Here's an example of a build YAML. It's another YAML file that you can create to build complicated steps of build. So the first step, I'm going to call it compile. It's an arbitrary name. The name is compile. The Docker file that it's going to use is dockerfile.compile, because you can have just arbitrary named Docker files. That runs. Then it does something that I don't know. It's a Docker file. Let's say it creates a project, an executable called Iron Mountain. It's actually a real thing. And puts it there. What I'm going to do with Habitus is going to go in there and pull that file out. So it not only does it build the image, it fires up a container based on that, goes to that container, pulls the executable out, puts it into your build context. So the next step, let's say API, can have an add Iron Mountain. And Iron Mountain will be available there. So I basically moved an artifact from one image to another one. I can have commands to delete as well. So this was what I was talking about when I was saying about private keys. So when I do something like remove RF, any SSH keys that's there, it doesn't just run that command. It runs that command, but also squashes it. It pulls that image layer out. So your image does not have any trace of your private key in there. And then that was the API. And then you have web, which is the same one. And I have the upload step, which at the end, it's just a Docker file that we've created. It's just S3 CMD, which is a command line tool to upload things into S3. Takes in my access key for Amazon, secret key, and uploads that into S3, my buckets, right there. And you can have dependencies there. So I'm saying my API depends on compile step, my web depends on compile, and my upload depends on both web and API. So it builds a dependency tree and then runs each step, multiple of those in parallel if they don't depend on each other. So any independent step will run in parallel for faster build. It does all of that with just saying, Habitus, point it to something, and get it running. As you can see, it supports syntax like environment variable replacement, so you don't have anything in your source control that has things like AWS keys or SSH keys and things like that. Any questions so far? OK, cool. Now, as I said, you can go to habitus.io, have a look at this. It's an example of how it works. It is open source now, so you can go to GitHub, see the source code, all that sort of stuff. And you can read about artifacts, how they move around between different images. The cleanup step, which squashes and yanks out layers from the images. Image sequencing, which is quite interesting. So you might want to do something like build one step, And the second step, from, is actually previous step. So not only do you move the artifact, you create the base image for the next step in the prior step. And you can run multiple of these ones at the same time on the same build machine. What it means for you is you can actually have a Docker build machine, a server in your office. Now what happens is all of you have done Docker in, well, most of you have done Docker in development, and you know when you want to build a Docker, you just go Docker build, and if you're unlucky and you have a file that you don't want to have on your local, you might have it add dot, and that file ends up in the image. If you have a build server, you can have a repeatable, reproducible, if I can say it, image build system. And for that to happen, you need to be able to do parallel builds. So if I commit something and it triggers a build, and my colleague commits something and triggers a build, they can run at the same time. So Habitus takes care of that by assigning a session ID to each one of them, tagging each image that it builds into sessions and trunks. So it can actually run, you can run multiple parallel Habitus instances parallel to each other. Step dependencies we talked a little bit about. Environment variables, fairly standard stuff. You can also run a command, which is like upload the image or whatever that might be. And that's basically it, and a bunch of command line things that you can do about how to find the Docker daemon and stuff like that. Okay, I'm just going to run it once so you see how it looks. Okay, so I actually forgotten the syntax. Okay, the work directory is -d. I'm going to point it to a Go language project that I have. Okay. I have a bad YAML file. So here's it's probably that dash. I have not run this part. There we go. It's probably not that. I'm just going to, sorry? I can't hear you, sorry. Shouldn't be. Dash. I'm just going to take this one out for now. No, okay. So I'm guessing there's a tab / space issue somewhere here. Oh, that's the well, that's the British spelling. Right. All right. I'm not going to debug it now. I guess it's my local build that's not working. But as you can see, like this one has tagging around it, so you can actually have tagging around that as well. And there's one caveat that we have not been able to solve, and there's something that if you guys are interested in a challenge would be great. And that is the squash part where it actually pulls out an image. It requires images, files within the Docker image to be moved out to temporary folder so it can be written back without the ones that were kind of pulled out. And it requires the Linux permissions on the file for GID and UID to be preserved, and that requires sudo, right? So if you want to run Habitus, you need to run it in sudo if you have a cleanup command step. If you don't, you can run it without that. And that's something obviously you want to avoid and not have if you can. But then again, it's a tool for your laptops or your internal build server in the company, so it should be okay. Everybody within the company is trusted. But ideally, you want to avoid that step as well. And that's another thing that's there. Okay, with that, I think I'm done. If you have any questions or anything you want to comment or ask, we'd love to answer it. Otherwise, thank you very much.
When Cloud66 is running analyze, that's
Yes.
the starter? When the GUI is running, it says analyze?
Yes,
It's
yeah.
running starter.
Actually, kind of yes and no. We have two products, Cloud66 for Rails and Cloud66 for Docker. And the Cloud66 for Rails does actually run that starter step. It's not starter itself, but pretty much what we built in starter is coming from those heuristics that we learned from how people put gems, where they put it, what they do with it. The analyze part on the other side is another thing. And that is, there are two ways that you can run Docker in production with Cloud66. One is, I have my own build system for Docker. It's working. I don't want you in there. I'm just going to give you a Docker image. I'm going to say, I have it in Quay.io, or I've got it in JFrog or somewhere, and it's my Docker repository, and it's built, it's QA tested, CI is run on it. You just pull that out. Here's my credentials. Go and pull it out and deploy it to my servers. In that case, Analyze really doesn't do anything. It immediately comes back and says, OK, I can check that your repository credentials are OK, and you have the image that you say you do have. But if you say, I have this Git repository, and here's my private SSH key, then what we do is we actually pull that code out. We run it through Habitus to build the image for you in a hosted way. So if you don't want to have your own build server in-house, you can actually use Cloud66 for that. And not only that, it builds it, and then we give you a private Docker repository to push it out to that repository, which is then available near your servers that you want to deploy it. So it just immediately pulls it out to the servers, and they get started. It also does things like versioning of it. So you can have a look at this, which is quite interesting. Because if you look at like our other stacks on Cloud66 itself, like internal services, probably one that we're running with Docker as well, you can see that we basically have like a build timeline. How many times we built that image, how many times we published it, as in rolled it out. So you can say, I want to roll back to that hash of the image. And what we found is quite as interesting is this. In the old school of way doing things, you have like this your Git repository, and you have a hash for each Git ref that everybody like commits and changes something, and it goes to production and say there's a performance degradation, like you have the site goes to slow. And then the sysadmins or the developer managers can go and say, site's slow, this deployment, what comment's gone into it, what's the issue? Somebody just said sleep 10 because they wanted to test something. Let's just say for the sake of argument. When you have Docker involved, you actually have two repositories. One is your code, the other one is your Docker repository. So there's like a break in the flow. As well as that, you might have multiple versions of your app running in flight. Like old versions are draining traffic, the new version is coming up, and the request goes slow, some of them go slow, some of them don't. You need to be able to say, this one is the new version, what Docker image hash it is, what's gone into that build, which code commits go into it. So there's like a long trace that you have to go back all the way to the commit line, where is that sleep 10? And it becomes much more difficult to find. And that's why something like this will help. So we call it build grid, and that's what the analysis does.
I had another observation.
Sure.
I ran the Hello World,
Yeah.
and I noticed there's a couple other Docker containers.
Couple of other?
Collect B service and 3 or 4 other services running in the when I fired up the Hello World.
Right. Yes. Okay.
With them.
Very, very, very good observation. So,
A very nice job too. I learned a lot.
right. So every server that you fire up with Cloud66 to run your application has these things. Your application, obviously, but it also has collect D, which is everybody's familiar with. It's an open source tool that collects metrics from your server, like how CPU is doing, how much memory do I have, how much disk do I have, and how much network backlog do I have. So that's what we use to show you charts on Cloud66 dashboard to see like everything, and you can put monitoring on it and all sorts of things. So I don't run out of disk space or things like that. There's also another thing that we run called Delphi, which is a product that we have, and that is a DNS server. It's a local DNS server. So every container that comes up, it actually points to that DNS server, which is a local one. And what it does is quite interesting because you can say deploy, deploy, deploy 3 times in a row because you had 3 commits that just gone in. And let's say you have a CI/CD that every commit, you have 20 developers, everyone commits, and at any time you have like 3 things going in. So you have 3 versions of your application in flight. You don't know what's now getting the traffic. The old ones are drained from traffic. You have a long file, large file being uploaded. You wait for that to finish to kill it before that, all sorts of things like that, right? However, let's say you have 2 services, web and API. If V1 of web, the old version of web, is asking for API, it needs to get the old version of API. If the new version is asking for API, it needs to get the new version of the API. Because you might have a contractual issue like the API is not backward compatible or whatever that might be. And this DNS is aware of it because you deploy with Cloud66. You know which version of which container has what version of your code. And just by the fact that it's asking that question from us that says api.cloud66.local, you know, your IP address is an old version. I'm going to give you an IP address of an old version of API or the other way around. And that's how it's a version-aware DNS service and service discovery. So that's what you see as Delphi running on it. It's Weave, which is our network provider. So we use WeaveWork, which is a company that we use for the basic network provider. And we chose IP address of 25000 because we realized that no cloud provider is going to build a data center in Yorkshire in England. So if you have a cross data center network, the IP conflict is going to be minimal. So that basically provides a seamless network between all your containers and non-container components like databases and other things. Any other questions?
Sure. We use Cloud66 and we've been looking into it at least.
Right.
We're not quite into production with it right now. But question for you, we're concerned about scaling.
Right.
So if a bunch of traffic comes in, we want to be able to scale up quickly.
Right.
And I guess that there's maybe 2 ways that we can do that. And I'm very bad with Docker. So maybe this is a stupid question. But so from what I've seen in the UI on Cloud66, I can easily add servers, put a proxy in front of it, and get like round robin kind of thing going on there.
Sure.
But it also looks like I could put more than 1 container on a box.
Yes.
So what's the difference?
What's the very good question? Yeah, that's a very good question. It's actually quite interesting. So here's an example of that. As you can see, we have 4 services. We have 4 services, so that was responsive. And this one's running 2 containers. Each one of them is running 1. It very much depends on the type of application that you're running. Now, an example of that would be Node.js. Node.js, everybody knows a single-threaded one, so you might want to have multiple ones so you can leverage your multiple cores. Another example of having the benefit of running multiple is like if you have something that drains a queue to send emails and you end up having a backlog because there's spike in traffic and emails that you have to send. But sometimes some applications could be multi-threaded themselves, so you can actually get away by having one of them on the server.
I'm talking about WordPress in my specific.
Okay, in that specific example, I'm not a PHP expert, and I'm not a WordPress expert by any means, but I believe that you can actually get away with having one instance of that because it sits behind Nginx as an application server. So the whole HTTP, what Apache will do for WordPress will be done by Nginx. The application server side of it is something that I'm not really an expert on, but I believe you can actually have one instance of the whole thing. But might be wrong. Any other questions? Sweet. Thank you very much. Go on.
I've got one. It's not specific to Cloud66
Right.
or even necessarily Docker in particular. Our current production app is running on Heroku, and we make heavy use of the proc file using non-web processes.
Yep.
We're moving to hosting on AWS with Docker images for a new project. if you're coming from a world where the number of instances for a given process are controlled via proc files
Yep.
and scaling the number of those up and down, what are some, are there any sort of best practices for how you would approach that in a non-Heroku based,
Right.
either continuing to use proc files and Foreman or tools like that, or something that manages multiple sort of Docker images?
Right.
or
Yes.
containers running?
Okay, great question. So the question is, using Heroku dynos and workers, you have a proc file. What is the best practice for people moving out of Heroku? And frankly, what we call ourselves, like we sit at the bottom of a PaaS cliff. People run on Heroku, everybody loves Heroku, and everybody starts with Heroku, nobody ends with Heroku. And people come to Cloud66, a lot of them. I would love for you to come and you should check out DigitalOcean. Better than Amazon. But no, in seriousness, what actually happens is we get this question quite a lot. Because Heroku obfuscates pretty much everything. There's a dyno and a magic and everything. There's no like a single unit of thing that you can take from one, say CPU cycle means CPU cycle. And a megabyte is a megabyte. No, there's like a dyno and like they have to rest nowadays and whatever that is. So there is a lot of magic involved, which means you cannot really translate that. And it's a very valid question. But my answer is, and this is something that I have to talk to my customers quite a lot, it very much depends, unfortunately. There is no magic bullet. It very much depends on what framework you use. Is it multi-threaded? Is it single-threaded? How much I/O bound is it? How much memory bound it is? So if you have a I/O bound process, means that you might have a single-threaded one, but that thread is going to get stuck because it's in a queue, or to write to the disk or whatever that might be. If it's not, just goes and comes back and responds to something, puts something on a queue, whatever that might be, then you have a different scenario. And how many users do you have to serve for that? As in, it's non-web, I understand, but it could be how many emails you want to process, or how many calculations you want to make, how many matches you want to make in a dating site. We actually had that problem, which was quite an interesting one, because there was this dating site who's actually still our customer. They have like 1,000 men and 1,000 women. Where heterosexual kind of matching would be like 1 million combinations of different things, and as every single new member will add another 1,000 calculations to who's the best match. So there was a lot of kind of dynos essentially working all those things. And it was very much depends on how long it takes. In that case, it was very much a mathematical thing. It was very fast for every single calculation, so you could get away with having a very CPU-bound distribution, not much memory. But if you have a lot of like Redis, it's very much memory bound. You have to think about that. I would be more than happy to help you on a specific case.
Sure.
Our team is, our support team is quite familiar with those things, especially coming from Heroku. But there's no magic bullet, I'm afraid. Sure.
I was curious if you were familiar with YesOn.
With?
YesOn, it's a moral equivalent of Rails and Haskell.
Oh, right. No, I'm afraid I'm not.
Have you guys deployed it or heard of anybody deploying it?
I'm sure if I look at, we have about probably 4,000 different stacks, unique stacks, and I'm taking out different environments of the same stack out. I'm sure there is that. I'm the least technical member of the team, so I'm afraid you're stuck with me. But I'm sure there is examples of that. I can dig it out. If you just send me an email, I'll put my email out at the end. If you send an email, I'll be more than happy to help you out with that. Well, my Twitter handle is there, but my email is cash@cloud66.com. Sure.
Couple of maybe two questions.
Sure.
One is I noticed that you offer like production, staging, development
Yes.
setups. Is there a difference between those?
In terms of performance, pricing.
Performance and pricing.
Right. So as far as performance is concerned, there's nothing that we do that degrades anything over another one. For us, the only thing that's different is a development environment. A development environment doesn't do backups and doesn't do load balancing, but it's free. So that's one side. As for anything else, you might say production, staging, QA, showcasing, whatever else, they are the same. What we find, however, is that many of our customers develop those things. You have like there is staging and QA on like DigitalOcean, and they have production on AWS or whatever that might be. and then they have a kind of a dehydrated version of the main thing on a couple of servers, one database and everything else in another server. So it degrades the performance, obviously, but it's way cheaper. And it's much faster to spin up. And then production goes into a full-blown, 50 front-end servers, 3 databases and whatever else that might be. And that usually works. We actually have a feature called failover groups, which allows you to clone a stack from one database, from one cloud provider to another, or one stack to another, switch the traffic over, do the database replication, cut it loose once it's up and running, and switch your traffic customers over.
And then the next question I have is, I think this is something that I've seen on like Google Cloud. They have so many different products, I don't know which one. But really, what I would like is to be able to git revert or git check out a previous version of my application, deploy.
Right.
What do you have like that? Like there's an easy way in the Google product where I can just generate a URL of a certain version of my application, send that to the client for them to review.
Yes.
Something like that in Cloud66?
So you can use any git ref that you have, whether it's a hash or a tag or a branch, to deploy that however you want. And that can be built into an image. So you can say, I want that version to be into this Docker image, and then that be deployed. And you can go to this page that I showed you here. If you go to the build grid page, this page basically, you can have different. These are different versions that are built. Now this one was deployed, but this one wasn't. It was just to see if the build works. So you can have each one of them deployed, and you can go back and say rebuild that, because there was an external dependency that wasn't in the version control that will change this build, which is not quite right. Or we can say publish this. We can publish this. And that is just a built image, which will just, all it takes is for the old containers to go away and the new ones to come in. There's no build step or anything else. It's basically just a simple Docker pull, start them up, give them network, and all sorts of other things that happens, but it's fairly quick. So you don't need to go through the whole deployment cycle.
Okay.
And you can also do that by putting it into your Git commit hooks. So every developer will do that, and the whole thing starts and it goes to production or to a staging. Sweet. Well, thank you, everyone. Thank you.
I'm Tommy Murphy. I'm from DigitalOcean. I've been here about 6 months and working on the delivery team here, where we're trying to make it easier for our developers internally to ship code. So we've got a few different dashboard apps, like our API. We've got some billing, asynchronous processes, a lot of storage management. We have a lot of just internal services that we run, and we're trying to make that easier to deploy. So one of the technologies that we've played and fought with here was Docker at trying to achieve that goal. So yeah, kind of like the why Docker. This slide should be self-explanatory. So we started out, we've got our CI environment is a drone, and that works by running your code inside of a Docker image. So when I got here, we had a Ruby base image that had 4 different versions of Ruby installed on it, used across 5 different Ruby and Rails projects, and there'd be Node.js installed for some reason and weird versions, and that's where we started out. Was this one base image that was just kind of everything was thrown into and difficult to manage. Then came along this project to do an isolated environment. So some new products we're developing, we needed to spin up copies of DigitalOcean, clone DigitalOcean, clone. It's a joke. So yeah, we needed, and a lot of our stuff is deployed with like currently with Chef on like droplets, internal like droplets for us. So like cloning all of DigitalOcean is kind of a big task. So one of the ways we like set about doing it was just for like each different project, we created like, we threw out the CI build image and created our own that was, you know, like based off of a like official Docker Hub image. So like off of Ubuntu or off of like the Ruby base image. So that kind of that knowledge of like what are the dependencies of this application reside actually in that application's repo. And then once we were able to do that to like a minimum set of our applications, we were able to like make a Docker compose that stands up a new like DigitalOcean. So that was pretty cool. And that's kind of where we're at, is like having, you know, different like specific Docker files for specific projects, and now we're like bootstrapping and running the CI within that Docker image, throwing out the old like one with everything else. And kind of where we're moving to is like a containers deployed in production. So like Borg, you know, Kubernetes, Mesos, Cloud66, right? You know, these different like platforms as a service where we will just develop artifacts and then make it easy for the rest of the DigitalOcean developers to have that artifacts running in production. So that's kind of like, we're like right about here. Halfway, we're not running fully in production yet, but many of the lessons learned from like the cloning of our like our infrastructure have been like iterated on these Docker files. So what I thought I'd do is just start off with like, this is from the Docker Hub or Docker Compose documentation for like a Rails application. It looks very similar to that one, where like it's from an image, install some dependencies, do the gem files, which is nice for the caching, a bundle install, and then add the rest of my application in. So where you may run into some issues, like first off is this Ruby 2.2.0 image, which it turns out like 2.2.0 is no longer a supported version of Ruby. So that Docker image doesn't necessarily get like updates or security updates. So, you know, I ran this a few weeks ago where I just looked at the packages in that base image that had like security updates, and there were 64 of them. So if you care about that, you might want to like have a plan for like dealing with like your base image, like contributing back up to Docker proper to say like, hey, update, you know, this thing needs updates. If it's an officially supported image, you'll probably want to be based off of an officially supported image. Yeah, and this is like OpenSSL had about like 15 CVEs in that like version of from the Ruby 2.2.0 image. So that's, you know, probably like one of the packages that's most relevant to your application, and like being able to respond to like vulnerabilities in that. So one of the things, like, since we're just running in like CI and locally and stuff right now, we can like ignore that for the most part. But when we like, as we go towards production, we want to have like plans in place to deal with that. So this is just something a bunch of Googling and Stack Overflow came up with to like update just the security dependencies in the Docker image. So it like adds an extra layer. And yeah, the Cloud66 products like of like squashing layers or adding this to a build would probably be like a good fit as part of like, yeah, spanning out your different Docker images. So yeah, back to the example. All right, you install some other packages. This is adding the gem files, and then you get to the bundle install, which was talked about previously, which is all well and good when all of your gems are like public gems hosted on like a Ruby gem. But the problem comes when you've got like something like this, where I'm referencing like another Git project that is a private repo, or like, on our like GitHub Enterprise, or somewhere else where you need like authentication in order to actually like fully complete the bundle install step when you're pulling in your other dependencies. So everyone, like, first off goes and like commits secrets. So like just don't do that. Like, stop it. So like if you add something like this where you have your token in, like, just stop it. We can solve this problem without like putting our secrets in our repository or the private key into the root SSH, which that was actually a good idea about like pulling that out if you're going to put it in your image. So we looked at it and had some like different ideas, is like, because when you're building the image, you're in like kind of a clean room environment. You don't have like all of the like SSH keys that you like normally have as a developer. So one of the things is like you could try to share the SSH agent with like the context of running the build steps. But actually doing that is pretty difficult with Docker to like share that into there. You could run like bundle install as like CI or developer, and into a special folder so that your developer is like pulling it as their identity, compiling the gems, and then adding that to the thing that can then be just like added into your repo, so that the bundle install step in your Docker file just like actually doesn't do anything. And you can like vendor the gems like just directly in Git, which is actually what we started out with, was bundle package. So this pulls the theoretically source-only gem and like caches it into a vendor/cache folder that should be platform independent. And so we were doing this as like developers could do that, and then just committed it to the repo. It didn't add like that much weight to the repo to have these like gem files. But the nice thing is that in your Docker build step, you have all of your dependencies like already with you when you're building. And that was all great and good until like on Friday, we added Google Protobuf gem, which publishes like platform specific. There's only about 50 gems that do this. And so like when you run bundle package on Mac or Linux or Windows or something, you get a completely different, like a pre-built binary. So that was annoying. And we're probably going to go to a system where like our CI uses the identity that cloned the repo to actually do the caching of gems. But yeah, it's just, there can be a lot of issues at that step that you might need to work around. And the takeaway is don't commit your secrets to something that's going to be in your Git repo history forever. And then the last step, this adding, right? You add the rest of your files into your application or whatever. So one of the problems is after this, everything like runs as root. So all of your add and like copy commands are going to be root, and any like since we didn't have like switch users as part of the Docker file or create users, you're going to be running your like infrastructure as root, which you may or may not care about because like depending on your like threat models. But it's just something that like if you want to run as not root, then you have to do a lot of different like adding layers to change ownership of files, like switch back and forth between like root and non-root. But we're going to just kind of ignore that and go with like Docker 110 was released recently, and it adds support for like namespacing to where the root inside the container is not your system root. And I don't think it's turned on by default yet, but we're just not looking at that problem since we're not actually like running it in production yet. But yeah, I think that's good things to come, I think, from Docker and like Rocket too, about running as a less privileged user, in addition to the other like benefits of running inside of a container. Boom, boom, boom. And then, right, so everything's root. Now, like, what do you run? When we stand up like our cloned environment, Docker Compose, we've just been running like the WebBrick server, right? But you might need to have like a faster like Unicorn or Puma or something, a different like application server that is before your like actual Ruby code, that does like things like the HTTP parsing, like you might have stuff for like TLS termination, things like that. Finding out like how much to put in the container and what to split out. Like you could run just like Unicorn here, but do you want like an Nginx like specific route for serving your assets versus your like it going through Ruby to serve assets? So there's a lot of different options there and how much you want to put within the container. We're kind of sticking to trying to stick to a one process per container model. So we're looking to run like Nginx separately in a separate container outside of our like Rails, Unicorn host. But yeah, it's another thing to think about on how much you want to put within like one container. And then just getting around to like your basic like 12-factor, like writing your applications, separating your configuration from your code. Even when you do it, we ran into stuff that like didn't work out well. So we had a lot of like YAML files that had configuration dropped with like data bags and Chef. So one of the, I think, things we did to make this much easier is instead of doing file-based configuration, we just took environment variables as kind of the least common denominator. And there's the Figaro gem or .env gem in the Rails ecosystem to do this. And like one of the areas that kind of like tripped up is the like development and tests. Like you can pass in just a database URL, but one of the things that like Rails or our spec does is like copy your development schema into your test, and it does smart things. So we separated like the database name for those two as like hard-coded, but we left everything else as just like configurable. And I think our database YAML is the only like YAML left, and it pretty much looks like this, of just interpolating your environment variables into it. Some other places where we had like things configured in ways that didn't work with like Docker and Docker Compose and arbitrary environments was like DNS things where we had hard-coded, or like you could put in like staging region or whatnot, but like when you don't have like an actual DNS to resolve that to, or like things need to be IP based, that got like we got bit by that and had to kind of refactor some code to make more things configurable, and like making just everything configurable, not just the host, but like the actual port you're on, the different like credentials to use. Just where possible, like configure the whole thing, even if you don't think you'll need to, because when you're running like 4 Redis instances and one like VM, you'll want to like change the ports. It's just like it's easier that way. So yeah, that was about it on the stuff that we've run into. Thanks for attending. I'm Tommy Murphy. You can follow my thought leadership on Twitter right there. And yeah, DigitalOcean, yes, is hiring. So yeah, are there any questions?
What kind of issues did you encounter when, specify a bit further about the DNS issues?
It was mostly just like things we're expecting there to be full DNS names. Like code was written with the expectation that this would be in DNS, but when like spinning up an arbitrary environment, like all we had to link the two containers, right, was like an IP address and a port. So it was basically just poor like assumptions made when initially writing code that you know, we thought it was configurable, but it turns out like, oh, it's not fully configurable to where we can spin up an arbitrary environment with it. Yeah.
Yeah, I got a quick question. Do you guys actually use like your own droplets internally for things, or do you have like a separate thing for that?
Yes, they're a little different than other droplets, but
Okay.
yeah.
What do you guys use for sharing environment variables across containers and yeah?
Yeah, so that's an active area of research, right, is how to get the configuration for like that third step of running everything in production. And yeah, one of the things we're looking at now is Kubernetes and just using the secrets feature of that, which isn't very complete. And then there's other like secret management solutions we're looking at, like Vault or that's another unsolved problem.
Can you say any more about Vault?
I've looked at it a lot. We don't have it running, but yeah. Is
Any
there?
reason that you're leaning toward Kubernetes over Vault?
Or just like simplicity to begin with, of like treat everything as like a secret, everything as an environment variable, and as kind of like a first step, I guess, at our like first iteration of trying to run some stuff in production in containers. Cool. Well, thanks for attending.